Welcome, curious minds, to a world of knowledge and discovery. Thank you for choosing our video on Sungrazing comet. Sit back, relax, and enjoy the ride. A Sungrazing comet is a comet that passes extremely close to the Sun at perihelion, sometimes within a few thousand kilometers of the Sun's surface. Although small sungrazers can completely evaporate during such a close approach to the Sun, larger sungrazers can survive many perihelion passages. However, the strong evaporation and tidal forces they experience often lead to their fragmentation. Up until the years, it was thought that all bright comets near the Sun were the repeated return of a single Sungrazing comet. Then, German astronomer Heinrich Kreutz and American astronomer Daniel Kirkwood determined that, instead of the return of the same comet, each appearance was a different comet, but each were related to a group of comets that had separated from each other at an earlier passage near the Sun at perihelion. Very little was known about the population of Sungrazing comets until 1979, when coronagraphic observations allowed the detection of sungrazers. As of October 21, 2017, there are 1495 known comets that come within solar radii. This accounts for nearly one-third of all comets. Most of these objects vaporize during their close approach, but a comet with a nucleus radius larger than is likely to survive the perihelion passage with a final radius of Sungrazer comets were some of the earliest observed comets because they can appear very bright. Some are even considered great comets. The close passage of a comet to the Sun will brighten the comet not only because of the reflection off the comet nucleus when it is closer to the Sun, but the Sun also vaporizes a large amount of gas from the comet and the gas reflects more light. This extreme brightening will allow for possible naked eye observations from Earth depending on how volatile the gases are and if the comet is large enough to survive perihelion. These comets provide a useful tool for understanding the composition of comets as we observe the outgassing activity, and they also offer a way to probe the effects solar radiation has on other solar system bodies. Our focus now turns to pre-19th century, an important aspect of our discussion. One of the first comets to have its orbit computed was the Sungrazing comet and Great Comet of 1680, now designated. It was observed by Isaac Newton and he published the orbit results in 1687. Later, in 1699, Jacques Cassini proposed that comets could have relatively short orbital periods and that it was the same as a comet observed by Tycho Brahe in 1577. But in 1705 Edmund Halley determined that the difference between the perihelion distances of the two comets was too great for them to be the same object. However, this marked the first time that it was hypothesized that great comets were related or perhaps the same comet. Later, Johann Franz Encke computed the orbit of and found a period of approximately 9,000 years, leading him to conclude that Cassini's theory of short-period sungrazers was flawed. Had the smallest measured perihelion distance until the observation in 1826 of Comet Q. In the following segment, we'll be examining 19th century in greater detail. Advances were made in understanding Sungrazing comets in the 19th century with the great comets of 1843 and 1882, and had very similar appearances and also resembled the Great Comet of 1106. Therefore, Daniel Kirkwood proposed that and were separate fragments of the same object. He also hypothesized that the parent body was a comet seen by Aristotle and Ephorus in 371 BC because there was a supposed claim that Ephorus witnessed the comet splitting after perihelion. Comet Q appeared only 2 years after the previously observed Sungrazers, so this convinced astronomers that these bright comets were not all the same object. Some astronomers theorized that the comet might pass through a resisting medium near the Sun and that would shorten its period. When astronomers observed Q, they measured the period before and after perihelion and saw no shortening in the period, which disproved the theory. After perihelion, this object was also seen to split into several fragments, and therefore Kirkwood's theory of these comets coming from a parent body seemed like a good explanation. in an attempt to link the 1843 and 1880 comets to the comet in 1106 and 371 BC. Kreutz measured the fragments of the 1882 comet and determined that it was likely a fragment of the 1106 comet. He then designated that all Sungrazing comets with similar orbital characteristics as these few comets would be part of the Kreutz group. The 19th century also provided the first spectrum taken of a comet near the Sun, which was taken by Finlay and Elkin in 1882. Later the spectrum was analyzed and Fay and Ni spectral lines were confirmed. Welcome to the next segment, where we explore 20th century and its significance in our journey. The first Sungrazing comet observed in the 20th century was in 1945, and then between 1960 and 1975 Sungrazing comets were seen and the 1965 comet Ikea-Seiki allowed for measurements of spectral emission lines, and several elements were detected including iron, marking this the first comet since the Great Comet of 1882 to show this feature. Other emission lines included K, Ka, Ko, Ni, Ku, and the comet Ikea-Seiki also led to separating the Kreutz sungrazers into two subgroups by Brian Marson in 1967. One subgroup appears to have the 1106 comet as the parent body and members are fragments of that comet, while the other group have similar dynamics but no confirmed parent body associated with it. Now, it's time to shift gears and explore coronagraphic observations. The 20th century greatly impacted Sungrazing comet research with the launch of coronagraphic telescopes including SOHO, SMM, and SOHO. Until this point, Sungrazing comets were only seen with the naked eye, but with the coronagraphic telescopes many sungrazers were observed that were much smaller, and very few have survived perihelion passage. The comets observed by SOHO and SMM from 1981 to 1989 had visual magnitudes from about -2.5 to 6, which is much fainter than comet Ikea-Seiki with a visual magnitude of about -10. In 1987 and 1988 it was first observed by SMM that there could be pairs of Sungrazing comets that can appear within very short time periods ranging from a half of a day up to about 2 weeks. Calculations were made to determine that the pairs were part of the same parent body but broke apart at tens of AU from the Sunday. The breakup velocities were only on the order of a few meters per second, which is comparable to the speed of rotation for these comets. This led to the conclusion that these comets break from tidal forces and that comets probably broke off from the Great Comet of 1106. Coronagraphs allowed for measuring the properties of the comet as it reached very close to the Sunday. It was noted that Sungrazing comets tend to peak in brightness at a distance of about 12.3 solar radii or 11.2 solar radii. It is thought that this variation stems from a difference in dust composition. Another small peak in brightness has been found at about 7 solar radii from the Sun, and it is possibly due to a fragmentation of the comet nucleus. An alternative explanation is that the brightness peak at 12 solar radii comes from the sublimation of amorphous olivines, and the peak at 11.2 solar radii is from the sublimation of crystalline olivines. The peak at 7 solar radii could then be the sublimation of pyroxene. Turning our focus to Kreutz sungrazers, let's explore its key elements. The most famous sungrazers are the Kreutz sungrazers, which all originate from one giant comet that broke up into many smaller comets during its first passage through the inner solar system. An extremely bright comet seen by Aristotle and Ephorus in 371 BC is a possible candidate for this parent comet. The great comets of 1843 and 1882, comet Ikea-Seiki in 1965 and Kulovzhoi in 2011 were all fragments of the original comet. Each of these four was briefly bright enough to be visible in the daytime sky next to the Sun's comet, outshining even the full moon. In 1979, SOLWIND was the first sungrazer to be spotted by US satellite 1 in coronagraphs taken on 30 and 31 August 1979. Apart from Comet Lovejoy, none of the sungrazers seen by SOHO has survived its perihelion passage. Some may have plunged into the sun itself, but most are likely to have simply evaporated away completely. Now, let's shift our focus to other sungrazers and embark on an intellectual exploration of its various dimensions. Taken with the Wide Field Camera 3 on April 30, 2013. About 83% of the sungrazers observed with SOHO are members of the Kreutz group. The other 17% contains some sporadic sungrazers, but 3 other related groups of comets have been identified among them, the cracked, Martian and Maya groups. The Martian and cracked groups both appear to be related to comet black holes. These comets have also been linked to several meteor streams, including the daytime Oratids, the delta Aquariids, and the Quadrantids. Linked comet orbits suggest that both Martian and cracked groups have a small period, on the order of 5 years, but the Maya group may have intermediate or long period orbits. The Maya group comets are typically small, faint, and never have tails. The Great Comet of 1680 was a sungrazer and while used by Newton to verify Kepler's equations on orbital motion, it was not a member of any larger groups. However, Comet Xison, which disintegrated shortly before perihelion, had orbital elements similar to the Great Comet of 1680 and could be a second member of the group. Brace yourselves for the next chapter, where we'll be dissecting origin of sungrazing comets. Studies show that for comets with high orbital inclinations and perihelion distances of less than about 2 astronomical units, the cumulative effect of gravitational perturbations over many orbits is adequate to reduce the perihelion distance to very small values. One study has suggested that Comet Hale-Bopp has about a 15% chance of eventually becoming a sungrazer. Now, let's shift our focus to role in solar astronomy and embark on an intellectual exploration of its various dimensions. The motion of tails of sungrazers that survive perihelion such as Comet Lovejoy can provide solar astronomers with information about the structure of the solar corona, particularly the detailed magnetic structure. Don't forget to check out my other videos for more valuable content.